So here's my Wireshark capture. This is router 2. Here's router 1. So let's start with router 2. We can see autonomous system number. We can see parameters, software version, peer topology list ID. Looks fine. What about this router? Okay, here's a problem. Notice parameters peer termination. So we can see straight away that there's a problem somewhere here. And notice here we can see a problem with the K value. So there's router 1. Here's router 2. Seems to be a problem with the K values. So if I scroll down, notice we're seeing different kinds of K values. So here we see K1, K2, and K3 are set to 1. On this router, suddenly for some reason it's showing 255. Over here, we're seeing 1, 0, 1. So we see 6 K values. The ones that are typically used are 1 through 5. Notice over here, 101 is used. Over here it's 111. So there's a problem with the K values. So I know that there's a problem with the K values. The routers will not form a neighbor relationship if the K values are wrong. So if I scroll down through the hellos, we are going to constantly see issues with K values. But this is what I'm interested in seeing. On this router, 3 K values have been set. On this router, only 2 have been set, so that's a problem. K values have to be the same for routers to form neighbor relationships using EIGRP. Okay, now that I know what the problem is, I'm going to start a Wireshark capture here again, and I'll show you in real time how to fix this problem. So once again, if I filter for EIGRP, what we should see is there's a problem with the K values. So the parameters of the one router are set to that, whereas the parameter on the other router is showing peer termination, and then it's set to 255. So we are seeing varying K values. This is the one I want to see. K values are wrong. If K values differ at all, the relationship is torn down, as you saw over here. So notice peer termination. Peer neighbor relationship is torn down because the K values are wrong. So what we need to do on the routers is fix those K values. Here's the console for router 1, and I'll open up a console to router 2. On router 2, you can see the problem. Router 1 also shows the issue. Notice K value mismatch. So show run section EIGRP. Show run section EIGRP. We can see the problem right over here. Notice metric weights have been set. They haven't been set on this side. You cannot have differing K values. So the way to fix that is to type no metric weights, which sets it to the default. I could have made the router 2 have the same K values, but in this example, I'm just setting to the defaults. Notice the neighbor relationship has come up. So an adjacency has been formed on both sides. Show IP EIGRP neighbor. We can see that a neighbor relationship has been formed from router 2 to router 1. On router 1, show IP EIGRP neighbors. Neighbor relationship has been established. Show IP route. We see EIGRP routes in the routing table. D means EIGRP, so show IP route. Routes are showing in the routing table. Hopefully that means that pings will succeed, and they do. So we've fixed the problem in this network. K values have to be the same. If they're not, the routers won't form a neighbor relationship. So if I scroll down now, notice here we suddenly see hello messages and then updates. That's because the K values are the same on both routers. Here's router 2, here's router 1. K values are the same, so they can update one another with information and tell each other about the networks that exist in the network. If the K values are different, they will not form neighbor relationships. K values have to be the same in EIGRP, otherwise it doesn't work. So I'll save this as TS fixed. If you want to download the working Wireshark capture. Again, I hope you're enjoying these troubleshooting videos and labs. Best way to learn is to practice.